what is buoyancy is. So as far as to define the word buoyancy, buoyancy is defined buoyancy force. For example, let us define first buoyancy force. Buoyancy force is the force which is exerting on the body when it is placed inside, when it is placed inside, when it is placed on the fluid, that is water. The vertically upward force exerting on that particular body is nothing but the buoyancy force. Or in other words, how do we define the buoyancy is buoyancy is defined as the fluid displaced by the body. The force acting on that particular body is equivalent to the fluid displaced by that particular body, right? So now what exactly this Archimedes is stating? The Archimedes states that the buoyant force, that is the fluid displaced, whatever the fluid displaced, fluid weight is equivalent to, when the fluid displaced weight is equivalent to the buoyancy force. The buoyancy force is equivalent to weight of the fluid displaced by the body, and it acts to the centroid of the displaced volume. It acts to the centroid of the displaced volume. So the force of buoyancy is given as rho f g into the v, where v indicates the volume, here in this one. Kindly note everyone, right? So where force of buoyancy is equal to rho f, so that is the density of the fluid into the gravity and volume of the body which is being placed inside that particular fluid. So that is the buoyancy. Even a hydrogen can be filled in the hot air balloons. Yes, that is also possible, right? So but depends upon the density. When you lower the density, the bodies will start lifting up. So it should be less than the 1.125 kg per meter cube of density. If you lower than that particular density, yes, definitely they will be flying into the air. They will be floating inside the air, right? Now the point comes to buoyancy and the stability. So now purely we are related with the buoyancy and the stability point with respect to the water. We'd like to relate it with respect to the water. So when you're relating the buoyancy and the stability point with respect to the water, here on screen we can see that as far as the stability is concerned, as far as the buoyancy, stability is. So let us discuss first about the buoyancy, then let us talk about the stability. So as far as the body is concerned, when I place a body inside the water surface or over the water surface, so in which case the body can sink down and completely reach to the ground. So in which case the body can reach and completely sink down to the ground. So whenever the density of the body is greater than whenever the density of the body is greater than the density of the fluid, then the body completely sinks down. And when I don't want my body to get sink down either, or it should not float up, but it should be stagnant in between the air only, in between the water only. So in that case, we will call it as a suspended body, where the density of the fluid should be equal to, where the density of the fluid is exactly equivalent to its density of the body. No, I don't want this case also. I want my body to completely float on the water, but partially it may get immersed into the water. I want my body to float up, but partially it is slightly immersed into the fluid, but it should not get like suspended body, or it should not get like a single body. It should be floating on top of only, but some of the body may get immersed into the fluid. So that case we will call it as, so where the density of the fluid is greater than the density of the body, in that case the body can completely lift it up. And now the suspended body, best example is a submarine. So how do these submarines go for a bottom? So that is the height variations. How do they make means? They will take the air, they will take the water available in the surroundings. They will take inserted in that water, and when the water is inserted in that one, so they will behave like in a suspended body. And whenever they don't need, so that means whenever the submarine want to float up on water, so they will release that water outside from it, and then it will be behaving like in a floating body. So it is up to the user or the mechanism we are going in that one. So when do we make the floating body? How do we make a suspended body? How do we make the sinking body? Now, okay, up to this point we are clear about it. So already we said that the force of buoyancy is equal to the source of buoyancy is equal to density into gravity into the volume displaced. Force of buoyancy is equal to density into gravity into volume displaced. So where V indicates that it is a volume displaced on that particular one. Right. So let us talk about the stability points more. So when we are talking about the stability, now we are talking about the stability of the immersed bodies. Now, as far as the stability is concerned, now, so it is very much concerned. So when we are talking about the bodies which is suspended completely inside the water, or it may be floating on water, or it may be completely sinking down inside the water. But while it's sinking, while it's suspension, while it is floating, whether the body is under the stability. So that means either if I say this is the upside and this is the downside, right? Either I'm going with the upside down and downside up. So this stability also is my interest. So for that's the reason to for that discussion, what we will do is we will categorize this stability into two types. We'll categorize the stability into two. So that means stability with the floating bodies is one, and stability with the immersed bodies is the other one. Stability with the floating bodies is the one case. So that means partially immersed bodies. So stability with the partially immersed bodies, and the other case stability with the completely immersed. So that is suspended bodies. Stability with the suspended bodies and stability with the partially immersed bodies. So let us see the first case one. So here when it is a completely so stability with the immersed bodies, suspended bodies. Stability is with the immersed bodies. So as far as here on screen you can see that whereas a fluid, so that is the fluid density of OF, and here the FB indicates that force of buoyancy. FB indicates that it is a force of buoyancy. FB indicates that the force of buoyancy. So here on screen we can see when it is a stable body. And now we are calling it as a stable body. So that means the force of buoyancy is being represented. Force of buoyancy point is being represented by B, and force of buoyancy is represented by FB. And here if you see G represents the gravity. G represents the gravity on it. So that means center of gravity point. Here the G represents center of gravity point, and W is the weight of the body. Weight of the body. So don't get confused. Here the W represents the weight of the body. Now on screen here we can see that the buoyancy. So that means the buoyancy point is above the gravity point. The buoyancy point is above the gravity point. Then whenever the buoyancy point is above the gravity point, then we can say it is a stable body. Whenever the buoyancy point and the gravity point matches on that particular body, whenever they are at the same point, so that means the gravity point and the buoyancy point are at the same level, then it is called as a neutrally stable body. And the other case, now the question comes, so when it is a stable body, you are seeing that the gravity is below the buoyancy point. What happens if my gravity moves up? What happens if my gravity above the buoyancy point? Whenever your gravity moves above the buoyancy point, the body will get completely reversed. So then we have to say it is the unstable body. So that is head down and tail up, head down and legs up. So head down movement will be happening in the unstable body. Now the question comes that how it has become the unstable there. So for that reason I have brought the one more picture on the screen. So you can see here there is something called restoring moment. So here in this on screen, when you see the restoring moment, whenever the force of buoyancy and the force of gravity, they are not aligned on the same line. When these 2 points are not aligned at the same line, so then when they are moving aside, so they'll start creating a moment on the body. And that whenever the two forces acting at a certain distance, this will result in the moment in the body. So this distance, whatever is available in between the force of buoyancy and the force of gravity, so this distance which is acting in that one, so this distance will result in the moment on the body, and that will start slowly tilting the body. So that moment we will call it as a restoring moment. And when your restoring moment, if it is not corrected at the restoring moment, the body will get completely unstable back. The body will be going for the completely unstable case. Okay, let us see. This is the case where completely body is immersed into the water. So that means completely a suspended body. This is completely a suspended body. So let me again review this one. So whenever the buoyancy point is above the center of gravity, the body will be stable. Whenever the buoyancy point, that is represented by the B, and G represents the center of gravity, whenever these two matches and aligns on the same line, then they are called neutrally stable. And whenever the buoyancy point has come below the gravity point, so the body is coming. So the shift of the buoyancy and the gravity point, when they are not aligned on the same line, but they are shifting, means the body is getting the restoring moment. So like you are saying rolling moment, like you said, rolling moment. So that type of moment can be achieved. So you need to separate that buoyancy point, where you need to separate some buoyancy point to this particular one. When you create the gap in between that, so that will start acting the moment on the body, and the body will start rotating. So that moment is called the restoring moment on this particular body. So now it's in your hand whether you want to make the bodies to be stable, you want to make it as neutrally stable, you want to make it as completely unstable, or you want to create a continuous moment on the body. So you just shift that particular buoyancy to the gravity points. You just change. Now let us discuss about the body. So the second one I told, under the stability I told, one it is a suspended body, another one it is a floating body. So when it is a case of a floating body, how exactly, how do we make it as a completely stable, or how it, when it is going for the unstable body, so that we should know about initially. So here the B represents the buoyancy point, B represents the center of buoyancy, that is the buoyancy concentration point, right? And G represents the center of gravity point. So whereas in the stable case, here if you see in the stable cases, when it is a floating body, in stable cases when it is a floating body, the center of gravity is above that particular one. We said that it is completely unstable body. But whereas in the floating bodies, whenever the gravity to the buoyancy, there is some distance, but they are aligned on the same line. They are aligned on the same line, but there is some distance available in between these two. So in that case, it is called as a, you know, now when you see the unstable bodies, what exactly happens with the unstable bodies is when your gravity, so that means center of gravity and the buoyancy points are not aligned on the one center line. They are not aligned on one center line. So then definitely this is going to create some restoring moment or turning moment of the body, and it will make that complete body to be unstable. So here the case is only it is aligned on the body, and the center of gravity point should be above the buoyancy point. Center of gravity point should be above the buoyancy point, and at the same time they should be aligned. So they both should be aligned on one line. So here you can see they are aligned on this line. So when your buoyancy and the gravity point are not aligned on this line, so then you can see in this picture. So this is the gravity acting line, and here if you see the buoyancy has shifted by some angle. The buoyancy has shifted by an angle. So then it will be completely an unstable body. Then it is completely an unstable body. Now the next question comes, sir. So how can you say that every time the bodies would be under the stability only? So that means every time will it be aligned on that one only? So because see some wind will be occurring on this one, or free wind will be occurring on that one, or wind strokes will be there in that. See, whenever we are traveling with this one, so in that case, how can you say that the body could be completely stable? Yes, there is a moment possible even on the floating bodies also. So whenever your buoyancy shifts, so this will start creating the body to create a moment on this body also. So that means your floating body, or the boat or ship, whatever you are calling it as, that will also start creating the moment. Accordingly, that will move on the body. That will also accordingly move, and it will create a net moment on the particular body. Now then the question comes, so I make that particular body to get stabilized, and with some little instability, if it is rising also, how I can get restored back, my body and make it stable, and to move inside the water, or move on the water, move on the water. How to make it move onto the water is, here you can see the second picture. So let me annotate it. Here on this one you can see. So that means in order to define that one, so when it is an object, when it is completely floating body, at the same time, so here if you see in this one, the buoyancy point has been shifted from the center line of action. We call it this line of action. Now when this particular point buoyancy shifts from that particular point, right? So it's like a simple pendulum. It's like a simple pendulum where you are holding a one point, and your body, that is the buoyancy, is available on it, right? So let me draw that. Okay, here about one point, if I notice it, about one point, if I'm taking it, so this buoyancy will be acting like this. So this is the line of action, not the point about which on the top, on the top, if I'm holding that point, so this bottom side moment can be controlled. If the bottom side moment can be controlled with the height rise on that one, so the height in between the buoyancy, and the control point is called as a metacentric height. The point between the that is M. So where the metacenter is defined as a point, about which the moments would be acting. So where the metacenter is a point about which the distance acting on that one, so that means the entire force would be concentrated with respect to this particular metacentric height. So for example, if I'm talking about the moment acting on this body, so that would be relatively, so with the radius of R. So that radius of R I can draw with the point from the M. So that is about the point this curves will be making, or this arc will be making about this particular one. So then it is called as, then that height in between that M and the B, so the distance in between the metacenter and the buoyancy point is called as a metacentric height. and that distance in between these two will be called as a metacentric height. So that is the distance in between the buoyancy point and the point where it is pivoted, the pivoted point to the point where the moment is occurring on the particular body by varying the buoyancy. So that height is called as a metacentric height. So here in this case, of floating bodies, the metacentric height plays a key role. So the metacentric height plays a key role. If you want to make a stable bodies, if you want to make the stable bodies, so that means you are BM, so the distance in between the buoyancy point and the metacentric height point, this is controlling the complete body. So if you are, as you move your metacenter above, as you move above your, as your M, if you move above, so what happens? The B will get closer to the G. And if you move lower, if your metacenter is moved down, so then again the moment would be again different on that particular body. So this is what we can see the yachets on the boats. This is what we see yachets on the boat. So where they are giving that particular moment. So that means the metacenter height has been calculated initially. So that is what even the large ships, they will be utilizing the yachets on it to control or to stabilize that particular body on it. So that is what stability of the bodies are being concerned. Stability of the bodies are being concerned. So we see as with respect to the metacenter height, so we can say that whenever the metacentric height, so that is if you are measuring in between the gravity point and the metacenter height, if you are measuring that, sorry, metacenter height is in between the G and the M. So that is in between the G and the M when you are measuring that particular metacentric height. So it is in between the G and the M. So whenever the distance in between the G and M is greater than 1, so here we are relating with respect to the G and M, the distance between the center of gravity to the metacentric point. So that height is known as metacentric height. If your metacentric height is greater than 1, so then definitely your body is going to be stable. So that means whatever the moment, if you stabilize in this position. But when it is less than 1, so that means how to make it less than 1? So you get very close to that. The distance between the GF, when you get close to that one, so here it will get reduced, here it gets reduced. So as you close, as the closer this M gets close to the G, so that means your stability are losing it. As I move in my M, body stable. That is the reason the yachets would be having quite large, long yachets. You may say that, sir, boat is very small, this much, but the yachet size, you see, sir, how much height they have raised in that one. So that is what they are utilizing, that metacentric height, in order to make that particular body stable for the larger wind forces even which is occurring on the particular body, or which is the moment, or which is the forces acting from the bottom of the water, or the waves which is giving in that one, that will make it to go for the stable one. So let us discuss about the stability points of the floating bodies. As far as what is exactly the metacenter is concentrated is, metacentric point is a point about which the total force is acting, or the line of action along with the right. So whenever we are talking about the G and M, so that is the distance between the center of gravity and the metacentric height. Whenever the metacentric height is positive, so then it is a stable equilibrium. When it is equal to 0, it is neutral equilibrium. When it is less than 0, that boat may go like this also. So that means the boat bottom side up and top side down. So that means the humans are there in the downside. They are already fallen inside the water, and the boat is still stable. So they will go for the instability in that case. So that is also possible. So that means we should be very careful about the metacentric height point and the theta we are giving. Theta we should make within that limits. If you are going beyond that limits of theta, that we call it as a pitching moment acting on that body, right? So that makes along that pitching or rolling motions. This is all actually when we are relating with the aeronautical concepts. How do we conclude about this one, right?